Cool. I'll just share my screen. Is my screen visible to everyone?
Yes.
Okay.
So we can see, yeah, there we go.
Okay,
Perfect.
great. Thank you. So hello, everyone. I'm Shiwali Mohan, and I don't know some of the panelists, so I thought I would start with a brief introduction. I am a senior scientist at the Palo Alto Research Center, and my research interests are focused on designing collaborative AI systems. And before I joined PARC, I was a graduate student with John Laird in the SOAR lab at University of Michigan. And even there, I was working on a collaborative AI system, the interactive task learning system, Rosie. So that's sort of like the background of how I approach cognitive architecture research. Is I really want to build these complex hybrid systems that work with humans and are helping humans achieve their goals. And so this talk is sort of an AI systems person's view of cognitive modeling. And I hope it's a unique view. I was very excited as I went through this research, and hopefully you share my excitement too. Oh, and this work was done with colleagues at PARC, especially Peter Piroli, who's another cognitive architecture scientist. And a lot of the ideas were formed while working with him. All right, so before I go into sort of my main problem, which is trying to build AI systems to help people learn how to perform healthy behaviors regularly, I wanted to sort of give a context of why I think this kind of research is very important. So I start with sort of the classical AI systems perspective view of the world, right? So we have the perceive, decide, act cycle. The AI system, say it's a chess playing system, it's perceiving the current state of the world. So this would be like how the chessboard is laid out. And it's trying to figure out what's the next step it wants to take in the world. So what chess piece it can move next. And to be able to do this decision making, what is critical is a world model, which describes how do you want to currently describe the state. And there are different ways to describe state, right? So deep learning models will directly go from pixels, like an image taken from maybe on the top of the chessboard. More SOAR-like systems will try to represent the state in a more relational way that captures some strategic information in the state itself. You might want to represent actions. Some SOAR-like systems will represent this as a hierarchy of task execution. And then you want to formulate some form of decision making. So you want to go from what's currently perceived in the state to what action should you be doing next. But this is sort of like a limited view of how AI systems are actually used in our world. Often, it's almost the case that there's always going to be a human involved in it. And the human is not just watching the AI system. That would be incredibly boring to just watch chess. I mean, sometimes it's interesting, but most of the times, if that was all the AI system was being used for, is to just play along, this would be a difficult thing to watch. What humans want is like, one thing would be for the humans to actually play against the AI system and try to win. So to develop an AI system that can play against the humans, you would need a human model. The AI system has to reason about what the human is actually thinking about, what kind of strategies are they following. Now, if you sort of slightly complicate the scenario a little bit, so what if the human is trying to learn and the AI system is trying to teach the human how to play chess? In that case, your modeling requirements will even become even more complex, in which you would actually have to try to model how do humans learn. So as the deployment scenario becomes more and more complex, the need for modeling the human collaborator in a human AI system becomes sort of stronger. And so there was this recent article in the AIJ journal which described what are the different ways AI systems model other agents. And it highlighted that there's really no good way of modeling humans in AI systems. All of the modeling techniques are sort of driven by gaming domains where you are trying to model the human as an adversary. So you might want to use game theoretic modeling, and then the AI system would do min and max search over that game theory represented state. But this is sort of like a very specific deployment. In general, so if the human is a learner, if human is a collaborator, you have to start thinking about the human model in a more sort of general, more comprehensive manner. And this is what has been driving my research for past few years, is that social sciences, cognitive psychology, behavioral economics, and even practitioners sciences like teaching have already described what kinds of models are useful, at least to the humans that are involved in those domains. Now, the question is, how do you take the social sciences models and then make the AI systems even better using these models, right? This is a good starting point, but it's not, so you can't really just pick all of these models and put them in an AI system. It's not a trivial task. You have to, so there are some gaps here and you have to bridge them. So the question is sort of, how do you bridge these gaps? How do you start from social sciences models, put them in an AI system such that the AI system can reason about a human collaborator and helps the human collaborator achieve their goals in the environment. So this is sort of the research agenda that excites me the most. And the sort of the rest of the talk is focused on one such type of problem. So this is the work that I did at PARC when I joined 5 years ago. And in this work, we were trying to build AI systems for supporting health behavior change in people. So it's sort of, I mean, everyone is agreeing with this problem now, that the problem is that unhealthy behaviors are associated with chronic illnesses. So like diseases like diabetes, cardiovascular disease, they're all associated with unhealthy behaviors. This could be just sedentary lifestyles, unhealthy eating, and things like that. And it used to be a problem of only wealthier populations of the world, but some data from India and other developing nations suggest that this problem is becoming worldwide, where people are indulging in unhealthy behaviors, which is leading to the sort of the emergence of diseases, even in cultures that had not known those diseases. So promoting healthy behaviors is important. So this would be something like taking a walk every day, or eating more fruits and vegetables, incorporating more plant-based diet in your diet. And the way to sort of achieve, and this is a hard problem, like people get it stuck into behaviors and then trying to move them to a different behavioral space is extremely hard. And what actually works is individual coaching, where a lifestyle coach or a nutritionist will sit with you. They will come up with a plan of how exactly you're supposed to be eating, how you're supposed to be journaling your food. But this is an extremely costly practice, and because of the costs associated with it, not a lot of people have access to it. So there's a significant population out there that's needing some support to manage their behaviors related to health, but there aren't enough support systems out there. To me, this problem is interesting because it's an extremely challenging AI, HCI, cognitive science problem. So for the AI side of things, usually when we design up AI systems, they're sort of transactional. You like imagine Siri, you said something to it, it did a task, it searched the web for you, and it came back. And that is sort of the end of its interactions with you. But if you actually have to help someone build on a healthy behavior, you have to come back to this person over and over again and really understand why they're failing, what could you be doing to actually help them get to their goals and things like that. So you actually have to model over a bigger time scale, and you have to be really robust to all the variations in how they are acting in the environment. So it's an incredibly challenging AI problem, and that's why it's super exciting to me. So to start building these kinds of systems, I started in a classical cognitive scientist type of approach, and we looked at like, why is individual coaching so effective? And the answer is, well, it's not a singular strategy. There's just no one way in which you could just sort of teach people how to do new behavior, but it's a collection. There are so many different strategies that are described in the health behavior change literature: goal setting, implementation intentions, motivational interviewing, and all of these really help people sort of build new kinds of behaviors. And what the human coaches are doing is what I call an opportunistic adaptation. So the first step is diagnosis. So if you have been to a coach and I told them that, they will ask you like, why didn't you go for did you go for a walk? And that if the answer is no, they would say, well, why? And then they will try to reason about why wouldn't someone go for a walk? And then you would want to do an intervention. So you might want to do certain actions. So if you want to build AI systems, you have to build the good kinds of human models to be able to do this kind of reasoning. So there are three characteristics for these kinds of models. One is that they're computational, like because it has to be integrated with algorithms, so it has to be computational. Second is it has to be causal and prescriptive, and this is very important. It's, you can't just describe human behavior. You actually have to sort of lay out the what if scenarios between actions and what would happen next, right? Because AI algorithms really need to reason about, if I did action A with this human, this is how their behavior is going to be evolved, and that helps AI systems evaluate the quality of action. So the model itself should be causal and prescriptive. And then the third is integrative. So because we are interested in really exploring different kinds of behavior strategies and how they all can be put together in an AI system, so the model should be able to explain different kinds of behavior change theories. So for this work, we explored the utility of the common model of cognition that John already talked about in his talk earlier this morning. And we said that, well, we already have this model of cognition, and which explains how does behavior originate in a human cognitive system. So we'll start there and we'll try to see if, like, what kind of guidance can we derive from this model to then build our AI system. So just very quickly, this is a picture of a cognitive model. John's picture had combined the declarative semantic memory and episodic memory together in a single box. But I separate this out and you'll see in a moment why. So we start thinking about how exactly would a health behavior or any kind of behavior would arise in this model, right? So imagine you are coming back from your office and then you notice that, it's evening, and you notice the park that's near your home in the environment. And so this context is brought into your short-term working memory. Now, what would happen next is that you may have a goal which says walk every day, and then the context associated with is that it's evening and there's a park near your home. So this is sort of like a prospective memory operation where the context brings a long-term goal into your working memory. And once this long-term goal is brought into your working memory, you can start applying your cognitive energy towards achieving that goal. So you may have certain things like in your procedural memory, things like if your goal was to walk every day, the behavior you're supposed to execute is take a 15-minute walk, right? And there may be several such behaviors that may get triggered because you have this specific goal in your working memory. And basically, you may have some other goals too, right? So several behaviors will get proposed and they start competing for cognitive attention. And then you have to sort of evaluate the utility of each of those behaviors and select one of them. And in that place where the episodic memory may play a role, where you are looking at all the experiences associated with different behaviors, and then saying, well, behavior one has been useful to me, so let me just try to execute that behavior in the environment. So you would go out and take a 15-minute walk. So this was sort of my understanding of if a behavior had to arise in the common model of cognition, this is how it would happen. And what was super interesting to me was that when I started reading the health behavior change literature, I started identifying all the behavior change strategies that align with different parts of the common model of cognition. So the goal setting theory sort of asserts that if there is no goal, there would be no behavior. This is most obvious for most cognitive scientists. But then there's this other theory called the implementation intention setting, which is sort of focusing on the parts that if you do not associate the goal with specific context, those behaviors will not arise. So this sort of is a signal to, well, the prospective memory function actually it works well in this environment, and this is what you should supposed to be doing. Periodic reminding strengthens the associations between the context, the concrete context, and the goal. Adaptive goal setting is it says that you have to help the trainee select goals that are difficult yet attainable, so it influences how the trainee is applying judgment to the goals. And then finally, some work by Peter Piroli shows that you can use your long-term episodic memory to then apply judgment, and this affects how people behave in the environment. So sort of we started seeing how all these behavior change theorists, people who are mostly focused on behavior, mostly on health behaviors, what they were describing were different ways to manipulate the human cognitive system and really and to influence people to build up healthy behavioral habits. So this was encouraging and I was excited about it. So what's next? Like, what do we do with this information next? So we went ahead and we developed a system Desiderata for, like, if we had to design a health behavior coaching system, it must have these Desiderata associated with it. So these are just really aligned with what the common model of cognition tells us and what other health behavior change theories tell us, right? So you create a high-level health goal. So you would, for example, you have to walk every day. Then you want to really help the trainee associate the goal with a specific behavior, right? So you want to just having a goal saying walk every day is not very useful, but you have to actually associate it with something extremely specific, like walk for 15 minutes every day. And then you want to associate contextual cues from the environment to the goal. And this helps in recall of that goal when the right context arises, right? So you might want to associate like the exact time and the trainee is going to be performing that behavior. So you might want to help them sort of remind themselves that they have to go for a walk at 5 p.m. in the evening. And then you can strengthen the association between context cues in the environment with the goal and sort of increase the possibility that the goal would be retrieved at the right time. And then eventually you want to create a stream of experiences that help the trainee evaluate this goal highly, this behavior highly as compared to other behaviors. And this fifth step is extremely hard to do, but we have some understanding of how to do this part, but yeah, it's not fully integrated into the system yet. So we designed a system. It's called PARCCoach, which sort of addresses a subset of the desiderata that we identified that I just described, right? So it's a health app. It sort of starts once you log in, it will first ask the user to select the health goal. So we have 3 different health goals and you could go down the list and help the person like pick the one that they really want to work on. And then we specify the goal by trying to associate a behavior with that goal. So we recommend 3 behaviors, people may pick one. We measure the difficulty, but like what do they think, how difficult that behavior is for them to do. Next, we go into the implementation intention setting phase, and this is where we are associating contextual cues from the environment with the behavior that the person is supposed to be doing, right? So we ask users questions like, which part of the day will you practice this? Who will you be practicing this behavior with, and things like that. And what this does is really connects the things that are happening in the environment with a goal, and hopefully, so for example, if you practice that I will be going for a walk every evening, hopefully then the evening comes around, sort of the goal of going for a walk just sort of pops into your memory and you act on it. Then using this information, we have a set of reminders where we are trying to strengthen the relationship between contextual cues and the behavior. And again, like this helps with the recall of the goal itself. And then people were supposed to record their goals and their performance on them. So we asked people like, did you report on your specific behavior? People could say, yeah, I did this behavior, and no, I didn't do it. And then we measure if this behavior was difficult. And then we also measure people's self-efficacy, which is your estimation of basically it's an estimation of your confidence, how likely you think you'll be able to do this persistently. So the question is like, how do you evaluate the efficacy of these systems? And that itself is extremely hard. The way we did it was we did it through a deployment study where we deployed this app to 60 participants that we recruited from various email lists. And what's interesting about this data set and what excites me the most is that this is like 4 weeks of 60 people using the app continuously every day, or what we hope like they're using it to actually maintain a record of their health behaviors. And this is the reason sort of this is exciting to me is that a lot of cognitive science and cognitive modeling studies are lab experiments where people are brought into the labs and they're given a specific cognitive task and then they're doing them and then they walk out of the lab. So it's not very clear to me that those findings could readily be generalized, even though there's a lot of evidence just because the kinds of the variety of tasks that have been done. It's a lot of evidence that these are more general, but like, how do we know? So the sort of this deployment study actually helps us sort of bridge that gap, because these people are doing these tasks in an ecological setting. They're not in labs, they're living their lives, and they are working on a goal that they have created for themselves. So having this data set was important. And I want to do a shout out to Peter's work, who built an actor model, fit onto this data, and it's a very cool, like, please look it up, very cool, precise actor model of habit building in people. So I'll very quickly go over the results, and I have a pointer to the paper that at the end of the talk, so please go and read the details of it. But we had several hypotheses, right? So the first hypothesis was that baseline ease of target behaviors improves compliance. So if you're trying to do something that's easy, that you are confident in, you're more likely to do it. But if something is very hard and you are not confident in it, you are unlikely to do it. So the coach should be able to sort of titrate the behaviors that they're assigning to you to your comfort level. And we saw some of this results in our data set that we have. So I'll just walk over the graph a little bit. The orange part, so the x-axis shows the difficulty. This is the highest difficulty task. This is the lowest difficulty task. It's increasing in this way. The orange or the yellow part shows how many, so we have how many people were absent, so they didn't even come into the app or report anything. Failure is how many people came into the app and then they said that they failed to do the task or the behavior they were assigned. And success is how many people came and reported that, you know, they were successful at doing that behavior at the time that they were supposed to do. So as we expected, sort of when someone is not confident at all, they're not really doing the behaviors, the success rates are really low. But when they're very extremely confident, they're doing those behaviors more. So like our Desiderata 2 was, the coach has to associate a goal, associate with the goal of behavior with appropriate difficulty. And if you titrate it right, you have people doing that behavior more. So that sort of supported our hypotheses. The second one was about reminding. So if you want to so you have to strengthen the association between the context in which a behavior is practiced and then the goal they're trying to achieve. And here again, this is the no reminders condition. These are increasing number of reminders. And as you see, like the behavioral compliance increases as you are giving more reminders. And note that these reminders are not typical reminders where like at 5 p.m. your calendar comes and says, go for a walk. These reminders were more interestingly designed, that they said things like, oh, this evening with this person, you were supposed to go for a walk. And it's trying to strengthen the association between the contextual cues and the behavior you're supposed to do. And what we expect is that the human cognitive system will kick into it the right context and then bring the goal into the working memory and increase the likelihood of behavior. And we saw some of that in the data set. Another interesting thing sort of is the additive effects of self-efficacy and reminding. And this is sort of a very cognitive architecture driven hypothesis, that because so this is super interesting because these two different strategies are attacking different parts of the human cognitive system, right? The reminding fact is attacking the human memory. The self-efficacy part is actually influencing how you evaluate different behaviors. So given the cognitive architecture hypothesis, you would expect an additive effect. And we saw that as well. Like if you look at these two sort of bars, these are same difficulty level, in which in this case, we did not give the reminders. In this case, we gave the reminders. And what like you don't notice right away is that the absent reports go way down. And it's because people are, if you sort of are reminding them, then they can, the behavior comes into their working memory often. And then the compliance increases as well. So this is sort of exciting in its way. And then the final sort of the cognitive architecture specific hypotheses was the role of episodic memory in evaluating behaviors and attacking behavioral compliance in that way. And we saw some elements of that too. So the number of successes that you have recorded into your app actually influences how difficult you think that task is and how confident you feel at at doing that task, right? So the number of successes, absence, and failures were significantly correlated with your measures of difficulty and self-efficacy, which is saying like as your experience builds up, your estimate of if you are able to do the task changes, and that in itself will change if you actually do the task, right? So for that, we saw the impact of average difficulty and its influence on if you actually did the task or not. And even there, we saw significant correlation between these behaviors. So basically, this evidence gives support to this cyclical hypothesis that as you are doing those tasks, you are getting more and more confident, and as you're getting more confident, you're doing them even more. So you're sort of seeing some indication of building an habit. So to briefly summarize, going back to the original question of human models, it's incredibly important to build collaborative AI systems. Human modeling is extremely important, but there's no general understanding in the AI literature. Social sciences propose models, but it's not really clear how you would put them in an AI system. You just can't sort of just plug and play. You have to do this work of bridging the gap. CMC is a good candidate because it's computational, causal, and prescriptive integrative. And what was exciting to us was that we saw a lot of evidence from health behavior change theories that were talking about the CMC. We use CMC to guide design of an AI behavior. And this is a not fully integrated AI system yet, so I picked at some design parts, but there's a lot of work that needs to be done. So I will pause here. I have only a few minutes for questions, but in case you're interested in knowing more details about this work, I have put up the citations. And it's not just sort of the cognitive science models that are useful. We have explored models from behavioral economics and practitioners' models as well to build better collaborative AI systems. So just in case you're interested in what these kinds of works, I have put up the citations. Thank you.
Thank you so much for your talk. We do have a couple questions in the chat. The first one is your goal to work with those who are in poor health to achieve basic health, or also to extend to those who are already athletic and want to improve performance?
So these apps were targeted specifically at people who were sedentary. So we picked clinical populations in some parts of the study, people who were already suffering from, were pre-diabetic and things like that. So these are designed for people who do not have any idea of how to think about their health and help them get to a healthy behavior. The athletics, the science behind athletics will be very different, and some people in sports research study that, but we were not looking at that.
Thank you. Another question. Things like difficulty, confidence, and judgment seem related to emotion. Have you considered incorporating emotion modeling into your system?
So we had, so I did not have time to go into the details of what exactly we were measuring, but we did have a questionnaire around affective attitude. So every day when people came back and reported their performance, they were also asked questions of like, did you enjoy it or not? And then we had questions around instrumental attitude, like, did you think this behavior is useful to go towards your goal? We did not see any correlations between that variable and sort of the reports. But it just could be that we did not design the questionnaire properly, or it needs a longer time frame study to be able to do this.
Thank you. The next question, how does this relate to work on perspective memory? Is this at a high level a way of manipulating it in people?
Right, so I think perspective memory is extremely important, and that's where the implementation intention research and the behavior change strategies around that are focusing on. They are trying to really connect your environmental cues with a goal that you have to do. And the stronger that kind of prospection is, the more likely that the goal will come into your working memory, and the more likely that you will actually perform a behavior to execute that goal. So the perspective memory definitely plays a role here. And then through implementation intentions and reminders, you are sort of strengthening your perspective memory in a way so that the behavioral compliance improves.
Thank you. Another question. How would you distinguish the effectiveness use of this app compared to Fitbit or Apple Watch that track people's activities, help set goals, and enable behavior changes?
Right. So a lot of that the role of those kinds of apps is more of like a journaling type of an exercise, right? So you are trying to make a record of what activities you are doing, how, what were you successful in that. But there was no like goal setting component to it, which what I hope to go towards this goal is like when you're working with a human coach, they're not just like reviewing what you did or recording what you did. They're also helping you set the right kind of goals and then implementing strategies that would help you during the failure cases, right? So if a coach sort of reasoned and sort of figured out that you're failing because you forget to do the exercise, they would come up with certain strategies. So this whole diagnostic goal setting part is what our work will I hope will contribute to this research. We can definitely try to incorporate data from these sensors to do more sort of truth tracking, right? I have a system that people have to report by clicking buttons, but they could be lying. So you could rely on data from Fitbit and things like that to sort of build out a training strategy. But yeah, that's what I found, that in Fitbit Coach and things like that, it's not really sort of goal-driven diagnostic kind of training. It's mostly tracking what you have done and then scripted next step to what you should be doing next.
Thank you so much.